Solving a differential equation using the Laplace transform, you find big Y of s equals the Laplace transform of y to be big Y of s. We want to find y of t, which means you want to find the inverse Laplace transform of big Y of s. To do this, our first step is to take the inverse Laplace transform of both sides of this equation. So we'd have the inverse Laplace transform of big Y of s equals, let's write this first Laplace transform as the opposite of the inverse Laplace transform of 1 divided by the quantity s minus 8, and then minus the inverse Laplace transform of 72 divided by s to the fifth, minus the inverse Laplace transform of 4 divided by the quantity s minus 8 squared plus 16. Now let's look at our table of Laplace transforms. Notice how we have y of t in the first column and big Y of s in the second column. So because we're determining inverse Laplace transforms, we'll use this table in this direction here. Let's see if we can find the formulas we'll use to determine these inverse Laplace transforms. Notice how here we have 1 over the quantity s minus 8, which fits the form of 1 over the quantity s minus a, or in our case a equals 8. So we'll use this formula for this first inverse Laplace transform. Here we have a denominator of s to the fifth, which fits the form of s raised to the power of n plus 1 in the denominator. So we'll use this formula for the second inverse Laplace transform. And for this last inverse Laplace transform, notice how we have a denominator that is the quantity s minus 8 squared plus 16. So looking at these two formulas here, notice how because our numerator is 4, which is a constant, we'll be using this formula here to find the last inverse Laplace transform. Notice this formula has the quantity s minus a in the numerator. Now let's work on making these inverse Laplace transforms fit the form of these formulas. So to begin, the inverse Laplace transform of big Y of s equals y of t, which is what we're looking for. So y of t is equal to, notice how this inverse Laplace transform fits this formula perfectly where a equals 8. So we'll go ahead and leave this in its current form. So we'll have the opposite of the inverse Laplace transform of 1 divided by the quantity s minus 8. Now here, let's go ahead and factor out the 72. Let's write this as minus 72 times the inverse Laplace transform of. Now looking at our formula, notice how the denominator is s raised to the power of n plus 1. So let's write this as s raised to the power of 4 plus 1. So we can see n equals 4. And notice how our numerator must be n factorial. And right now it's actually 1. So let's write 1 as 4 factorial divided by 4 factorial. In this form, we do have a 4 factorial in the numerator, but in our next step we'll have to factor out 1 over 4 factorial, so the numerator is just 4 factorial, not equal to 1. And now for the last inverse Laplace transform, looking at the denominator, notice how the form is the quantity s minus a squared, so a equals 8, and then we have plus b squared, where b squared is 16. So let's write the denominator as the quantity s minus 8 squared plus 4 squared. So again, we can easily see a equals 8 and b equals 4. Notice how the numerator must be equal to b, which in this case it is because the numerator is already 4. So we can leave this inverse Laplace transform in its current form. So now our next step, let's leave this first and third inverse Laplace transform the same, and here we'll factor out 1 over 4 factorial. If we factor out 1 over 4 factorial, we'd have minus 72 divided by 4 factorial times the inverse Laplace transform of, and now we have a numerator of 4 factorial and a denominator of s raised to the power of 4 plus 1, and now it fits the formula perfectly. And this term stays the same. So we have y of t equals, here we'll have the opposite of this inverse Laplace transform where a equals 8 is going to be e raised to the power of 8t. So we have the opposite of e raised to the power of 8t. Let's go ahead and simplify 72 divided by 4 factorial. That'd be 72 divided by 4 times 3 times 2 times 1, or 72 divided by 24, which equals 3. So we have minus 3 The inverse Laplace transform, where n equals 4, is t to the fourth, so minus 3t to the fourth, and then finally we have minus this inverse Laplace transform, where again a equals 8 and b equals 4, would be e raised to the power of 8t times sine of 4t. So this is our function y of t, which is the inverse Laplace transform of big Y of s. Going back to our first slide, this is what they're asking for here. We have the opposite of e raised to the power of 8t minus 3t to the fourth minus e to the 8t times sine 4t. I hope you found this helpful.